Uh, Great. How's the volume? Okay. Not quite as. I'm going to give you my main message right up front. I've tested 4 fungicides against Phytopthora Rubi, and it looks for the most part like everything is good. All the isolates are sensitive for the most part to the fungicides. So that's the main message up point. I'm not seeing major resistance out there, but I'm going to present all of this. Couldn't have done this without all of you. As a federal employee who is here to serve the American public, and that's you, the growers, I thank you for letting me access your fields to get these raspberry Phytophthora isolates. Again, we could not do our research without you. Thank you so much. Chris, Lisa, Tom, and Inga were a big help in getting, collecting samples and helping me find fields. And then Brian and Kim in my lab helped assess these Phytophthora isolates for resistance. So big overall outline. I'm going to quickly cover what is Phytophthora, why should you care, what was the study about, what are the results and the conclusions. Briefly, Phytophthora is a very common pathogen. If you grow raspberry, it's more than likely that you have Phytophthora in your fields. It's in the soil. It loves wet conditions. So this time of year, Phytophthora is extremely happy. It rots the roots, so it's killing the roots. It's very hard to control. And one reason it's hard to control is it produces these spores, which are very thick-walled. That makes them resistant to penetration by fungicides. It makes it resistant to chemical and environmental degradation. They are there long-term. Based on surveys that I've done and previous surveys, most of the Phytophthora that you have in your fields is Phytophthora rubi, but I did find some related to Phytophthora megasperma, so I'm going to be presenting results on both of these Phytophthora species. So why is this important? Basically, like I just said, Phytophthora is everywhere. If you're growing raspberry, I really probably will easily find Phytophthora in your fields. It's devastating in wet, heavy soils. And here you're seeing about 100% incidence. It is a huge problem in those wet, heavy clay soils, and you can tell this has quite a bit of clay from how much these are clotting up. Not good. But even in light, fluffy, sandy soils, it can cause mortality. Here are some plants that have started dying out. So it does cause death even in low amounts in the soil and light, fluffy soils. And even when it's not killing, it can cause plants to be stunted, chlorotic, sort of yellowing, sickly plants. So this is a big deal for raspberry production. Also, why is this important? There are reports out there from you guys that often disease control does not work well, and that disease control isn't lasting as long as it used to. So one of the questions that I've been getting is Phytophthora becoming resistant to fungicides. There are 2 major fungicides that you've been using up to this point. One is Mefenoxam. This is the active ingredient of Ridamil Gold. The other is phosphorus acid, also sometimes called phosphites, phosphonates. These are in products like Allude, Aliette, Agrifos. There are tons of products out there with phosphorus acid as the active ingredient. So overall, what this study was about was, is Phytophthora resistant to these fungicides? And then to look at 2 additional fungicide chemistries in case we found resistance in Mefenoxam and phosphorus acid. We wanted a backup plan that you would be able to use if there was resistance out there. So I sampled 24 fields. There were 4 fields sampled before me by Jane Stewart and Nick Grunwald's lab. 18 of those fields were in Whatcom County. That's why it's a darker red. 5 were in Skagit. 3 were in Clark, and then 1 each in Pierce and Cowlitz. So that gives a distribution of where all the samples have occurred. We ended up with over 150 Phytophthora isolates. This includes the ones collected by Jane Stewart several years ago. And basically we did a Petri plate assay. All 150 of those isolates were tested with the active ingredient from Ridamil Gold. And then we did a subset of 50 with phosphorus acid, oxothiopyperlin, which is Arondis, which has recently been labeled for use in raspberry, and dimethomorph, which is not labeled for raspberry. This is basically what a Petri plate assay looks. Up here at the top is a non-amended, there's no fungicide in those plates. You can see the Phytophthora is pretty large diameter colony, and down at the bottom is the highest concentration of fungicide. And this is how we tell how sensitive an isolate is. And the reason we focused on 150 isolates with Mefenoxam is this is the fungicide that you're using right now that we deemed was the most likely where you would find resistance. When you look in the scientific literature, you don't find a lot of resistance to phosphorus acid. So this is what I showed last year. Last year I indicated to you on the y-axis here, basically the higher up a dot is, the more tolerant a particular isolate is to the fungicide. So this one here in orange is Phytophthora megasperma. Everything in orange is megasperma. Everything in blue is Phytophthora rubi. This was the most tolerant isolate of all to Mefenoxam. And then along the x-axis here, along the bottom, whoops, is all 150 isolates. So last year I said, you don't need to worry about resistance. There is some variation here, but resistance is capped at 100. Basically, you consider an isolate resistant if it reaches 100. None of these isolates are anywhere near 100, and I thought I'd help visualize that by, here's the y-axis here going up to 6. So if you want to see what it looks like capped at 100, that's where we would expect to find resistant isolates. All of the isolates are down there way, 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 way low. I'm not worried about resistance amongst these 150 isolates. The other thing I mentioned last year was Phytophthora megasperma is about 3 times more tolerant of Mefenoxam than Phytophthora rubi. But when you look at this scale with 100 being resistant, all of those are just so sensitive to this fungicide, it's not a big deal. Then the second point I want to make is the concentrations of fungicides that we're testing in Petri plates is very, very low. Basically, if we used 100 gallons, it would be like 0.17 pints per 100 gallons per acre. That is way, way, way below what you're actually applying, which could be up to 3.6 pints per 100 gallons per acre. And so that 100 resistance line is down here in orange. The amount that you're applying is way, way, way up here at this red line. So again, I am not worried about resistant isolates being out there, despite the fact that I'm hearing inconsistent control with fungicides. And there are other potential reasons for that. If we look at this in another way, I got to thank Tobin Peever for thinking about it this way. If we look at the percent control, or how much fungicide at each concentration reduces the growth, at this 0.17 pints per 100 gallons, most of the isolates are controlled 80 to 100%. That growth is reduced 80 to 100% at this very, very, very low concentration. So if we raise it up to what you're actually applying, I expect that we would have 100% growth reduction across the board. So I hope that's sufficiently emphasized. Now we'll quickly go through phosphorus acid. Again, this is a subset of approximately 50 isolates. The big take-home message here is that Phytophthora rubi almost across the board is 100% growth reduction at the concentration we tested. What concerns me is that we tested this concentration way above what you're applying in the field. So we tested up to 6.5 pints per 100 gallons per acre, and the label is at 4.5 pints per 100 gallons per acre. You can't go up that high, and I'm a little concerned that Phytophthora megasperma, some of the percent growth reduction is around 80%, but in the literature, Phytophthora megasperma is not considered as aggressive as a pathogen as Phytophthora rubi. And I think there are ways that we can actually improve control with phosphorus acid that aren't currently labeled that I'd like to get tested. I looked at I looked at a big number of phosphorus acid products. Most of them are foliar applied. That confuses me because we've done a rhododendron test that's affected by another Phytophthora species. And we've compared foliar application of phosphorus acid versus soil application. Foliar application of phosphorus acid does basically nothing for Phytophthora root rot control on rhododendron. And I wonder if we can do some experiments in the future to compare a soil application of phosphorus acid versus a foliar. And I think you're going to get better control with phosphorus acid if we can get the label to change for soil application. And this is the only fungicide we tested that you do apply to the foliage. And that's where I would go next with phosphorus acid. Oxythiopyprilin, basically everything is sensitive. If we look at 100% growth reduction, it looks like, you know, we have some isolates in the 60 to 80% reduction. And then for megasperma, we've got one that wasn't controlled at all. But if we look at what we tested very, 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 very small amounts. And you compare that to the actual label, you're looking at 10,000 times more product that you're applying according to label than what we tested in the Petri plates. So I expect that that basically all these isolates will be sensitive. We are going to do some further testing at higher concentrations to make sure of that. But I think oxythiopyprilin looks like a really good product at this point for control of both Phytophthora rubi and megasperma. And lastly, dimethomorph. This, again, is not labeled, but it's been used to successfully control root rots in other crops. It controls Phytophthora cinnamomum root rot of avocado. And potentially in the future, if there is resistance developing, this might be a good product. Again, across the board at the very, very low concentrations that we tested, near 100% control for Phytophthora rubi. Megasperma, not quite as good a control, and again, that same isolate is down here over at the 50 mark in the lower right-hand corner, not controlled at all, but the concentration that we're applying is so low, I expect at the application rates that would be on a label would be sufficient to cover this, and we're just going to double check these isolates that show more tolerance just to make sure that they are controlled. So conclusions, really there is no evidence for fungicide resistance out there to the two major fungicides that you guys use, but maybe there is a little bit of reason to suspect phosphorus acid isn't as effective for Phytophthora megasperma. That said, a Petri plate assay is not a field environment. So although a Petri plate assay can give us an idea of how sensitive these isolates are, disease control is a whole other different ballgame because you've got the environment thrown in, you've got your field thrown in, you've got the plants thrown in. And so really to make this sort of statement, I have to test this in the field and make sure that phosphorus acid is effective for Phytophthora megasperma. That fungicides, I think I said that correctly, phosphorus acid is effective for Phytophthora megasperma. So why might disease control be poor out in your fields? One, these fungicides have a very short action time, typically around a month, maybe a little longer than a month, depending on the environment. They don't last terribly long. So one application isn't going to carry you throughout a whole year. The second thing that I've seen is if you're applying it in fall and then a bunch of rains come through and there's a lot of water flowing through your field, you're essentially diluting your product. And remember, Phytophthora loves water. So that's when populations start exploding. And you can have such a high inoculum pressure that it overwhelms any fungicide that you might have there. And I think that might be one reason why we see failure out there. There could be an application timing issue. Maybe you need to apply more than once a year. Maybe you need to apply in a season besides the fall. And it might be also a matter of how many applications do you need in a year to achieve control. All of that, of course, plays into potential residue tolerances, but that's something to think about for future research. And finally, especially in terms of phosphorus acid, we really, I think, need to compare foliar versus soil application. I don't think foliar applications are going to be optimal for your control of Phytophthora root rot. And at this point, I think my best advice for all of you is to continue rotating fungicides of different action. You've now got oxythiopyprilin in the mix, and my understanding is it's being sold in combination or in a pack with Ridamil Gold, so you can alternate the two fungicides. I think phosphorus acid is also a great product. And with that, I don't know if I have time for questions, but thank you very much.
One very short question is that I'm not familiar with what phosphoric acid is. I'm used to either the leaf feed type or the dry material. But what is phosphoric acid then?
So phosphorus acid, it's very, very different than a phosphorus fertilizer. It's basically a fungicide that's supposed to not only enhance plant defenses, but it's also directly toxic to the fungus itself. So it has sort of a two-pronged action. That's one reason why people have been applying it to the foliage. They think it stimulates the defenses in the host. But I'm arguing that it doesn't go in high enough concentration down into the roots to provide control. So it is a fungicide.
Well, but does it also classify as a fertilizer?
It does not classify at all as a fertilizer. It's in a form that is not available to plants as a fertilizer, and the fertilizer form does not have fungicidal activity.
Any other questions? Anyone?
I see a question.
Yes, there's a lot of phos acid formulations on the market, and they're not all labeled as disease curing products. But would you comment at all on what kind of concentrations would be needed of phos acid to be efficacious?
Basically, the concentrations that we've used in mine, I don't have data on raspberries, so that's the first and most important caveat. But for rhododendron root rot control, we're finding 4.5. The concentration shown here is effective for Phytophthora root rot control in rhododendron. Completely different host, completely different Phytophthora species, but the label is proving effective for us for Phytophthora root rot control in another system.
Yes, but there's a lot of different salt formulations out there of phos acid. That's kind of my point. Is there
Got it. So AI. I would have to look at what the actual active ingredient concentration is for mine, and we have not done enough that I could compare the products in terms of activity, because the phosphorus acids are available in different formulations and different types. It's not been, I don't have an easy answer for you, and it's complicated.
We've had some experience using copper sulfate on Cactorum, Phytophthora cactorum, very low rates through a drip system. Have you looked at copper in these species that attack raspberry?
We have not looked at all at copper, and it was something I overlooked, and I really don't know. I'd have to look at the label whether it can be applied to soil or not, because I imagine for Cactorum it's all above ground. No? Below ground? On apples. Okay, good to know. I'll keep that in mind and write that down.
I have a question. When would you use it though? Like right now or spring or?
It's not been worked out. I mean, we have a label. We have a bunch of labels, and my understanding is most of the fungicide application for all of you is in fall. Is that correct? Yes, no?
No, spring, summer.
Any of the fungicides. Are all the fungicides for Phytophthora root rot used in the fall? No. Okay, so phos acid, foliar in the spring.
A little late, Daryl.
Yeah, there aren't a lot of, unfortunately, there aren't a lot of studies out there for me to tell you. The published fungicide studies are few and far between, and I can't think of any major ones on raspberry, so I don't have recommendations for you at this point. It's something that we would need to design to test and see when do we apply and how often. So,
Thank you, Jerry.
all right, thank you.
Okay, we're going to switch gears.